Okay, so we're going to look at water. So we want to talk about one of the major properties of water, and that is that water is a polar molecule. Now, from your chemistry lesson, does anyone tell me what it means to be polar? Okay, Trevor?
One of the atoms is larger than the others and kind of taking over.
Yeah, you're kind of on the right path, yeah? Okay, Donovan?
It's negatively or positively charged.
Okay, good. Okay. So let's kind of add those together real quick and think about what that necessarily means. So basically, oxygen is more electronegatively charged. Okay, so that word electronegativity, I know you've heard that before. Who can tell me what being electronegative means? What, Garrett? Okay. So what does it mean to be electronegative? So being electronegative means that it likes electrons. So with that being said, okay, so if you are a polar molecule, you also form a covalent bond. Now, who can tell me what it means to be covalently bonded? What do you do? Trevor?
The atoms share electrons.
Right. So you're sharing, and if you're more electronegative, that means you don't share as well. So you want the electrons more. So by virtue, what happens here is oxygen holds electrons, so it becomes partial negative, and hydrogen becomes partial positive. And so what you end up with is a molecule that has partial negative oxygens and partial positive hydrogens. Well, negative and positives do what to each other? Okay, but in the world, a negative opposites do what? Attract, right? So what it forms is it forms this little bond right here. Okay? So this positive and that negative like to link up with each other. And that little linkage right there is what we call a hydrogen bond. So it's a hydrogen bond. The major thing I need you to know about a hydrogen bond, it is an extremely weak bond. Okay? And if we think about the little activity we just did, we were able to hydrogen bond using what? Soap. Okay? Soap breaks hydrogen bonds. That's why when you wash your dishes, you use what? Soap. Without the soap, the water wouldn't really interact with the food particles or the dirt or anything like that, or your body. Like when you wash your body, use soap. Okay? Without soap, water is basically ineffective as far as doing what it's supposed to do. The best thing you can hope for is you get enough velocity of water to like push it away. Okay? If you want it to actually interact, that's what the soap does as it works its way through. So that's a very important concept to make sure that you kind of have wrapped around, because this right here, this here is the reason. That right there is the major bondage of life. Okay, this is what holds life together. This is what allows life to be life, is through a hydrogen bond and through this polarity, being a polar molecule. Now, a couple other interesting things about water. Okay. Water, and I'm just going to abbreviate that H2O, because hopefully we all are aware that is water. Water has a high specific heat. Now, I know for those of you that have PwC with me, we did specific heat. You should have done it in chemistry. Okay? Can someone tell me what the role of specific heat is, or what specific heat does? Trevor?
The amount of energy needed to change the temperature of the molecule.
Right. So it's the amount of energy needed, and it's actually, the specific heat is the actually, we need. Now, you may be thinking, the thing is the amount of or energy for a rationale for this. Ocean. Outside, but if it's going to be what? Cold. Okay? So until that water actually gets warmed up, which is as it goes through the summer and there's more sun and the summer gets hot, it'll eventually warm up. And then later, as we're ending pool season, okay, even on kind of a cooler day, that water's still going to be what? Warm. Okay? And that's the nature of it having a high specific heat, which is very helpful as we go through. The other thing, ice is less dense. Oh, there we go. Ice is less dense than water. Yeah, just holler at me if I'm off screen. This is an exception. So normally when you take things from liquid to solid, what happens to their density? They get more dense, and therefore they should sink. The nice thing about this, because of this, is ice floats. So ice gets to float. And then you got that happy little penguin that gets to live on top of the ice because it floats. The next box is I want to talk about a word called capillary. Capillary action. And what the capillary is when water flows up. Okay? So water actually can flow upwards. Defies gravity, right? Because think about it this way. When you water a tree or a plant, where do you put the water? On the ground, in the roots, right? Where does the water need to be? In the leaves. So somehow, magically, water's got to get from the bottom to the top. Okay? And so that's what we want to kind of talk. That's called a capillary reaction. I don't know if you all have done it recently. They've changed their methods. But at the doctor's office, they used to like prick your little finger and get some blood out of it, and they squeeze it for a while. And they used to have a little tube that it would the blood would go up directions. It's the same kind of idea here. So your blood's made a lot of what?
Water.
Water. Okay? And so they would squeeze it, and that blood would actually run up from the same principle that a plant uses here. Okay? So what I want to talk about is two terms that are very important here. Okay? Is the word cohesion. And that's when water sticks to itself. You should have seen that. If you brought one droplet close to another droplet, what happened to them? Cohesion. They want to be together. Okay? They're stuck together. The other word that is needed here, and I'm going to show you in this picture in just a minute, is adhesion. And that's when water sticks to something else. So have you ever noticed you got that last sip of something in the bottom of your cup and it will not come out? That's adhesion. It's stuck to the cup. It doesn't have to be a liquid. It can be a solid or something like that. Or as water sticks to the side of a glass. Or something of that nature. So that's adhesion. So what happens is, in a plant, we have cohesion. And cohesion has a lot to do with hydrogen bonding. I'm just going to say H bond. And then over here, I've got adhesion. So where it's actually stuck to the side of the plant. The plant, basically, just like a person, has veins and systems in it that allow the movement of water, minerals, and stuff to come through. And so using that together, it actually pulls the water up. You can think of water as like a giant chain. And so it hooks onto it and it starts pulling it up little by little. Okay? But it's really fragile. So if you do anything drastic, the water kind of breaks and it falls apart at that point. Okay. Everybody with me? Everybody good? Perfect. Okay, let's go to the next page. We've got a couple of boxes down here to play with. So you're probably aware of this, but you don't really think about it. Water is a great solvent. Okay. Can someone tell me what a solvent is? Solvent? No. Oh, come on.
I only had half of chemistry.
Okay, well that would be why. Victor.
It dissolves stuff you put in it.
Right. Okay. All the stuff we put into water. Anytime you make anything, it's always put it into water, right? Because water is an amazing solvent. Okay? So really, because it's a good solvent, almost anything can be dissolved in water. Okay? So almost anything can be dissolved into water. And because of that, here's what's key. Water carries all the minerals / elements for life. Okay? So as we move things around in our ecosystem, in our environment, to and fro, and into our bodies and out of our bodies, a lot of it's all through some form of water. Now, over here, and I heard a couple people mention this word, so kudos to you. Water has and I'm going to put it in quotes because it's relative, strong surface tension. And what happens there is hydrogen bonds join to allow the water to form and I'm going to put this in quotes too, a sheet. Okay. Getting off kilter. So it gets to form a sheet. So we've seen little bugs stand on water and things like that. And I put strong in quotes because is that really strong? No. Okay. So like a lot of things don't stand on water. Okay. Things like that. So we have to work other way. But comparatively to the size of it, if we think about water, to us a bug isn't all that heavy. It doesn't mean that lot, but it's actually pretty big and pretty heavy compared to water. And so for it to be able to stand on water is pretty awesome. Okay. And this is also why water can beat up and roll away. Yeah. Sheet, like a sheet. Yeah. Yeah, my E got a little funny there. It's the water to form a sheet. So it kind of forms that sheet. We're not going to fill in the bottom two boxes because they're not important as far as the depth we're going. So we're not really truly learning the true chemistry of water. It's just getting us enough. For those inquiring minds want to know, it has to do with heat of vaporization. And the last one talks about the last box here. I think that's supposed to be a picture of the moon. So the idea is look for another planet looking for water. Okay? To sustain life on another planet, it's all about water. If we can find water, because water is kind of the key to life at that point, and that's what we want to look for, and we're at.